Okay. Okay. So, okay. Let me go quickly. This is noteware. I hope that everyone can read it, and it's about the IPR and some conduct policy when you're joining IETF meeting. So please read it. If you have any concerns or issues, and you can talk with me and AD someone. Yeah. Okay. This for this meeting we also need the blue sheet. Blue sheet we already is already getting around. Yeah. So anyone, please sign on the blue sheet. Okay. And Jabber scribes, we need a Jabber scribes who can help us on this. It's mainly to bridge the remote voice to here. Roman, can you do us a favor? The Jabber scribe.
Sure.
Yeah, thank you. And we also have a note taker. Yeah, okay. Okay, thank you. Okay, let's go to our agenda. We currently only have 1.5 hours this time, so it's not very long. And we have 9 or 8 draft here. So I think time is limited. So I suggested that everybody to come here to present and discussion to provide comments. We should be careful about the time. Okay. So today, I think you can see the order. Firstly, we were talking about our hackathon interoperability test result. Okay. Okay. I know your point. Yeah. Sorry. There's a mistake here. I think I will switch the item 6, about the how to use a signaling channel to signal the ACL filtering change. This item 6 should move to before the hackathon reports, and because they are two related issues, we can put together and discuss together. Okay. This is a little change. But nothing else is changed. So we have multi-homing, we have server discovery document, and we have the co-home document, and we have also two or three new use cases brought from different operators. So today I think there are that's all we have today. We need to for discussion. Okay, is there anyone who want to bash this agenda? Okay. I think, maybe I missed one page or not. Before our presentation, I just want to give a very quick overview of our current status of the working group draft. As I had said, for this very basic protocol draft, including the requirements, architecture, and the signal channel and data channel. All these drafts are in the very final stage for publication. So I anticipate that in the following next month, they will one by one to be published as IFC. So I think that's a good progress. So our AD, do you have any addition for this? For this progress.
This is Ben Kadek. Yeah, so I think that's absolutely right. There's a few things that are sort of waiting on me. The requirements draft, I have to check that all the AD comments got addressed, and I can send it to the RFC editor. The signal channel and the data channel should go on the IESG agenda probably for the April 11th telechat, if I can get those done real fast. So I got a lot of work left on the plane ride home.
Okay, thank you. Yeah, great.
And to finesse on the architecture, the Roman Genedio, on the architecture draft, I'm handing over Shepherd responsibility to Valerie. And with why it's still in Shepherd write-up is the IPR check is not done. So if you are an author on the architecture draft and you have not yet responded on the IPR concurrence, please do that so we can proceed forward.
Okay. Yeah, thank you, Roman, for your information. Okay. I think that's our current status. So today, I think we don't want to spend time on this on those major draft. all the time is will be spent on the new draft and some left draft. So why not we start from the first one? Kanami, it's your turn. Okay. Okay.
Yeah, thank you for introduction and the changing of the agenda. I'm Kanami Nishizuka from IETF Communications. Okay. Then this draft is one of the outcome of the last IETF hackathon. So then this hackathon, we checked the capability of this specification. So that's why the agenda was changed. Then this is about the control filtering rules using the dot signal channel. Then this is a quick reminder for the new to this draft. Then the model in the data channel of activation type of ACL has already changed to these three types, like activation, when mitigation, immediate, and deactivate. So then over signal channel, we can turn on and off, or that means changes of these activation types by signal channel. So then we can get more flexibility to the anti-DDoS operation. So this is initial problem. So here describe how to control the ACL over the data channel. Can I see that? It's not fitting the. Okay, that's good. Thanks. Yeah, that's nice. Thank you. Then during the attack time, so there is a heavy traffic from the upstream of the transit line or circuit. Then the dot signal channel can survive. However, that channel cannot survive in this kind of hostile network situation. So only signal channel can communicate between the dot client server in this situation. However, before the without this specification in this draft, we cannot control the ACL, which was already installed via data channel over signal channel. Oh, this is slightly the more suitable one. Then the use of the data channel during attack time is not an option. So the signal channel. Also, the problem was that the signal channel does not allow the control of ACLs. So the solution is adding the leaf to the model of the signal channel of the changing of ACL list and ACL name and activation type. Okay, then other use case is about the activate of the this is about the deactivation of the ACLs, but also we have the use cases of the activation of the ACLs. So this, then here is some recommendations about the using of these specifications. However, these points will be discussed in the after the hackathon report, I think. So let me introduce the main 2 points. Then in current draft, dot client must not use the filtering control over dot signal channel if no attack is active. It means this control is not allowed in peacetime, but we'd like to discuss about this point. And also the third step, ACL-related clouds are not included in a put request used to send an efficacy update, get response, and delete request. Then also this point can be discussed after the hackathon report. Okay, then again, this kind of new specification was the outcome of the IETF 103 interop. So this works intensively done during the between the IETF 103 and 104, this IETF. So our received comments were already addressed. So I'd like to thank to many reviewers. Then I'd like to request the working group adoption of this draft.
Is there any comments or question for clarification of this issue and their solution? I think this draft is a good one, and it's from our hackathon test. It's really identify some problem and they want to solve it. Yeah. So and currently I think in this version, it's fifth version, is relatively mature. Yeah.
Yep.
From my personal idea. Yeah. So can I ask how many people has reviewed this draft? Oh. Yeah, it's good.
Yeah.
Yeah.
But also, could you elaborate the past use cases from yourself? Could you? So, could you elaborate? Could you give to the working group about more detailed about the past use cases?
Yeah, I think that I fully agree with Frank. That this is really a real problem. We had two tracks to solve this. Whether we integrate this solution into the base spec, but given the advance of the signal channel specification, I think it was too late to include it, because it's only an augment, which is a simplified augment, and then some, I would say, some use cases to illustrate how we can use of this new attribute. So for me, this is something which is really straightforward, solving a real problem. Again, with a limited scope. This is only the conflict coming from the same clients. We are not solving the conflict coming from other clients of the domain. So this is something which is really out of the scope. And the current specification, I think that's, we, thanks to the many reviewers and the feedback we received from the working group, I think that's, we were really prompt here and reactive to that. So the current version is stable enough to be considered for working group adoption.
Thank you.
So Roman Danilio, kind of a question. How much more discussion do you think we need to resolve that? I guess why I'm asking is, yes, the specs are on a track for publication, but we have not published them yet. So we could easily kind of pull them back and insert what we need and kind of put them back. So I think there's a trade-off to have that conversation, and it would help me to kind of summarize that, and I'll let Ben kind of figure out his position as well.
Yeah, I think it's perhaps this is for Ben. This is only procedural, because this part was not last called at the IETF level. So, but it's up to for me, if the working group decides to inject some of this work into the base spec, I can do it easily. But then the problem is that if we are sure that there are no side effects there to be covered, for instance, during some of the questions that will be raised by Kanami during the as a feedback from the hackathon, I am not sure if this will require more discussion or if there are more resolutions. So from the extension point of view, it's simple, just one attribute, because the other ones are already there. But once it comes into details, are we sure that we covered all the, I would say, the border keys and so on? So it's up to the working group to decide that.
Though this is a simple extension to the dot signal channel draft, it's kind of muddying the water that you create the ACLs using dot data channel and then control them using signal channel, right? The implications of that, I think it takes some more time for the working group to digest and come back with feedback. So I like the proposal. I'm a co-author of it, but I would like more time to digest and implement and interrupt and discuss this draft.
Yeah, just one further addition is that if we import this into the signal channel, the data channel will become normative reference to in the signal channel, which is we are looping inside the same document, which is not always a good point.
Okay, as a contributor, I have a question for the author. I think this draft has opened the door that we can use signal channel to control the existing data channel information. So do you think Of course, currently it's a corner case and the exception, but my concern is that if it's possible that there are more and more this kind of thing, I don't hope to see that, because we try to divide them for different functions, right?
Yeah.
But currently combine them in some level.
Yeah, I think that the answer is no. We don't want to expand I would say, this functionality to something more than just enabling or disabling the filter itself. Okay. We don't want to communicate or to convey the filtering rules themselves in the signal channel. We don't want to have redundant functionality between the buzz channel and the signal channel. This is only when you have something which is blocked, you have to unblock the situation, because otherwise the mitigation won't be successful. So it's just one simple signal there to say enable or disable, and that's it. We don't want more than that.
So we have a general consensus that we will just for some very specific case, we need some minimum modification. Okay, but we do not follow this way too long, right? Okay. Okay, I think Kanami, you have another presentation about the hexon, right?
Yeah.
And in that presentation, you were also talking about the test of these things, right? Of this document.
Yeah, right.
So please finish that one, and we can discuss the working group adoption. Okay.
Yeah, that's good.
So Roman Danilo again, before we move on. So by continuing the discussion, we're saying we're not going to update the base spec. Is that right? Is that what we want to do?
Yes, I'm hoping so.
Yeah, I think I can agree on the separate two documents.
Please also discuss as soon as possible and give us answer. Maybe after the meeting, not now. Okay, give us answer. Okay. Which way do you prefer to proceed this? Okay, hexon.
Okay, so then we did the hackathon last week about the interop testing of DOT protocol. So I'd like to share the result of them. Oh, could you do the screen again? Okay, here is a brief history of hackathon. So we have done the 6 hackathon consecutively. Then this time, that was the 5th interoperability testing. Then here is the hackathon plan of this time. So we checked the specification of DOT protocol. Then we checked the latest specification of signal channel and data channel. Then in addition, we have checked the new specification mentioned the previous presentation. Then interoperability testing of these specifications was done with 2 individual implementations. So one end is the OSS from our side, and the other end is the proprietary from John. Then we made several proof of concept demonstration of signal control filtering. Then here's a test target. So Godot, which is one of the OSS, has a functionality of dot client server. Then on the other hand, the Secure, which is a proprietary, has the functionality of client, server, and gateway. And each has a different type of mitigation functions. Then the test was done in both peacetime, idle time, and attack time. Then we checked these features of signal channel and data channel. Then here's the summary of the result. So upper matrix shows the test result of signal channel, and bottom is for data channel. Then green cells shows the test done before IETF 103. Then blue cells show the result of the internal interop before this IETF hackathon. Then orange is done by ourselves in this hackathon. Then you may see that almost over 90% of features are covered by our interoperability testing.
So my a quick question: what is the left 10%?
Yeah, I think gateway function, redirection, the happy hours function is already implemented in the secure. So there was no interoperability testing of these functions. So there could be done after some implementation implemented those functions, but it's not done. So that's why I just said it's 90%. Then this time we checked the blockwise transfer, which was already in the RC7959. Then it worked well, so there was no significant issues. That's good news. Then also, as I said, we did interop testing of signal control filtering. Then during the hackathon, we updated the code intensively because there was several bugs. However, those are solved. So then we checked that there was no significant issues, but we have several clarification questions. So it will be raised in the latter slide. Then also, we did proof of concept of use cases in the draft, like this. Then here's a short wrap up of this hackathon. So it is remarkable that we have included 4 new members, and then they contributed the OS project. So this must be the good news to us and this working group. So then this is a brief summary of the signal control filtering use case, but we can skip it because we already talked about that. Then this is the questions about the signal control filtering. So message of signal control filtering includes these 2 parts. One is the mitigation request, and the second one is the turning on and off of ACL. So how to treat these fields is our question. Then we have discussed with John about the treatment of these fields. So then we got these thoughts during the hackathon. Then first one is that a request include ACL list. We trigger a mitigation request and turn on and off of ACL. So both red box and blue box can be treated at the same time. Then get the response of that mitigation ID will be treated as if it is a mitigation request only. So this is already noted in the draft. Then the third point is the change to ACL is declarative. So it means delete of this mitigation request or expiration of lifetime will not affect the final state of the ACL. Then these questions were raised among us. So let me introduce these points. So one is about the first point. So should a mitigation request create a mitigation before doing the put plus ACL rest against the activation, or just send the put and ACL list location once is okay.
Yeah, if Mohamed Oukader, so if we just focus on this first question, yeah, in the current specification of the filtering control draft, there is no such precondition. We have three use cases in the draft. The first one, the third one, the first create the mitigation, and then the gate control into the filtering. We have the second use case in which in the first mitigation request, we alter the filtering itself because the client has the knowledge of the filtering installed on the server. So there is no reason so far to restrict that if we want to get control on an existing filtering, to first send the mitigation request and then send an updated another mitigation with the filtering rules. So far, this is both are allowed in the filtering specification draft we have, and they don't see so far a reason to restrict it to one way or the other. Both are acceptable.
Okay, so if so, we can send the put and ACL list first. So if so, those mitigation requests can be treated as should be treated as mitigation request in attack time.
Yeah.
Right.
Yeah. You are talking about sending the signal, using the signal channel to send the put method with including an ACL list. This is what you are talking about. So this is during attack time. You will contact your server to say, hey, I'm suffering from an attack, and please, once you are doing mitigation, just disable or enable or do this modification on an existing filter. This is the current rationale in the draft, and both use cases in which you first create the mitigation and then to receive a notification from the server that there is a conflict, then you decide to send to update your existing mitigation, or because you have already knowledge on the filtering which are instantiated at the server, you decide in your own when you send the first mitigation request to include the ACL list. So both make sense, and there are use cases for both.
Yeah.
So we should not, at least so far, I don't see a valid reason to assume that the first mitigation request must not include ACL list attributes, if that is the question.
Yeah, I agree with Med. I don't see a reason to put the restriction in the draft. I don't see a reason to put the restriction that mitigation request needs to be sent first after following a mitigation request with ACL. For example, I see a multi-vector attack and I see that my whitelisted IP addresses are being used as attack traffic, source of attack traffic. Then I may want to just send a mitigation request with the ACL rule to deactivate that. So it should be allowed.
Yeah. Okay.
Kanami, your time is out, so can you just I want to ask you all of these questions where whether you solve it or not, will them influence your document, or it's just some implementation progress?
Okay. We need clarification of these points, I think. So I'd like to ask the working group all of these points, but the time is run out, so we can continue the discussion on the mailing list.
Yes,
but,
yes, that's what I mean. Yeah, please send them in the mailing list and have discussion with experts here and get answer. If you solve all these problems, and I think the draft we can move forward. Okay. So what's the left content? Okay.
Okay. Okay. So the first point is the major problem. So second one and also third one can be treated in the mailing list after this working group, I think. But this is not so significant issue. So it must be yes. And okay. This I'd like to hear from the expert about this point. But okay, this time I can skip the discussion about this point.
Yeah, just for the previous one.
Okay.
So for this one, this is already clarified in the data channel. We have both examples in which there's the protocol which is used, and the other example in which we don't. This is on purpose, in fact, because these are only, I would say, redundant attributes, and it doesn't make harm to include them. The point is that the server must make sure that there is consistency in the attributes. For instance, if you are including protocol number 17 and then you include TCP clause, this is a problem. So the server will return an error code to say this request is invalid. This is not only about I would say, the protocol. This is also if you are, for instance, indicating the SCL type IPv4, but then at the core you are setting IPv6. So all this kind of stuff is, I would say, it's under the responsibility of the dot server to make sure that the information that you are setting to the server are consistent. It has to do this check. This is covered in the, I would say, in the specification what code must be returned, but the exact details of the consistent check is up to the implementation.
Okay.
So for this one form, it's allowed. If you don't include the port number, the port number will be inferred from the layer 4 match attribute that you include. So there is nothing to be clarified in the data channel because we have already both examples that cover whether it is included and the others whether it is not included.
Okay. Thank you. I agree with the statement. Yeah. Okay, sorry, I had run out of time, but I'd like to emphasize that most of issues about the core specification are addressed so far. Then we can move on to the next. Also, a signal control filtering spec gives a useful switch for turning on off of ACL. And it's proven to work during this hackathon. So I'd like to call for the working group adoption of this draft. Okay, that's it.
Okay, any question or comments? I think we're run out of time. So for this, for your previous draft, I think like what I said, I think it's already under several rounds of improvements. I think and tested, so it's okay. But I still want to encourage more people to read it. Okay, to read it and give your comments on the main list, and we can discuss to implement it. And
Yep.
Okay.
Okay.
Okay. Give me some time to decide whether
okay.
how we proceed with this document. Okay.
Okay. Yeah.
Okay.
Yeah.
We can discuss offline. Okay. Thank you. Next one is about the let me see multi-homing. Okay. Sorry. Wait. Okay. Multi-homing. Okay.
Thank you, Frank. So this will be a quick recap on the latest updates on this draft. So just this is for, if you can just put it on the full screen.
Cannot work? It should work. Oh, this. Oh, okay.
Yeah, so this is a fresh document that was accepted recently by the working group. So since the adoption of the working group, we have made some, I would say, minor changes there. So that we received during the call for adoption. So many thanks to Dan Wing and for the and the others who provided some inputs. So the first one is it was about, because in the draft we are separating both the enterprise CPE and residential CPE. It was not that evident why we are making this distinction in the document. So we introduced some text to clarify what is really specific to the enterprise CPE compared to the residential one. The main point there is that, for instance, in the residential CPE, we are not assigning provider-independent addresses. So this is typically will implement the way you will contact and you will select the upstream, the server. We have also made some clarification whether once when you have to select the server, you have to select the one which is really associated with the link from where you have been assigned the prefix. There are also some minor editorial changes that we introduced there in the draft. This is still an early version of the specifications, and we would like to hear from the more comments from the working group and to review and to share with us what are, I would say, if there are any issues that need to be covered so far. From our side, we have identified a list of points that need to be clarified. There is this text about the Unicast. In various points, in various sections of the document, we are disrecommending the use of the Unicast. So the point here is to make sure that we are using in a consistent manner the recommendation about the Unicast. The second one, because I'm a little bit personally skeptic about the use case document. So I would like to avoid having, I would say, strong dependency of that one. So we will work together with Tiru to relax that constraint and to have something which is really, I would say, independent of the use case draft. There are some other technical problems there or not. We don't know so far. We have to double check that. is about the server selection. When you are multi-homed, but you have a list of servers that are provided to this client, is how to run the server selection. Whether you have to go through the list or you have to contact them sequentially and so far. There is this issue about the MID. The MID is the mitigation identifier, which is assigned by the DOTS client when it has to send the DOTS request to a DOTS server. In case we are doing forking is that means we are contacting multiple DOTS servers simultaneously. So the point is whether we will use the same MID for all the requests, or we have to maintain a context for each server, even if we are doing forking. There is also this point about determination of the mitigation request. If we are under provider independent case, that is the same prefix which is assigned by multiple transit providers. If in one attachment we receive the signal from the DOTS server, for instance, which is saying that he has done and implemented the mitigation, but for the other side, there are another network attachment from where I am still receiving the attack. So how should you terminate the mitigation in the case we have the provider independent case? So these are at least the 4 items that we would like to work on for the next revision. And as usual, I really recommend and I would hope that we receive more feedback from the working group so that to make sure that we are on good track.
The MID forking case is an interesting one, right? I mean, it brings problems that SIP faced, right, where SIP user agent sends one request and it's forked by a proxy. How do you aggregate if one dot server says it's success and the other says failure, right? I mean, I think we should try to avoid those scenarios because it's going to complicate the handling of aggregation of responses and then partial successes and partial failures. Maybe the client should identify the multiple servers and reach out to each of them. So that would simplify and avoid the forking use case.
Yeah.
Can I ask how many people has read this document about the multi-homing? Okay, thank you, gentlemen. But still not so many. Yeah. I have a personal suggestion as a contributor. I think current draft you have listed several ways to do the multi-homing. But I don't see the pros and cons comparison between them, or some general guidance of in which use case we should use which mechanism something.
Yeah. So do you want the recommendation at which level? So we cannot make a recommendation at the network level. So we have the practices how multi-homing is done today. So we cannot just say if you are doing multi-homing, you have to go for provider independent or provider aggregated mode and so far. So this is the assumption that we had in this document. Is that there are practices that are installed there. So if we plug the DOTS service mitigation above that, what will be the implication? Without trying to go back downstairs to say it's bad to do for this model or not. That's the rationale so far, and I don't know.
Maybe I rephrase my request. At least I think if you have a table and to in the last of the document and to do a summary of the listing the different ways, because currently you have I think more than 4 or 5 ways to do this multi-homing. There are a lot of content there, so there are summary in the final part. Maybe it's my personal suggestions.
The readability is always a matter of test sometimes. So please, if if you have a suggestion to enhance,
I will share it. So, I just want to say that actually for this draft we already vote for the working group adoption several months before. So I think we get good feedback from the main list. So I think we can follow proceed this procedure and adopt it as working group draft, and we keep on moving, improving it.
Yeah, this one is already adopted. That's not.
No. Let me see.
This is the multi-homing draft, where that comment was relative to the server discovery draft.
Oh, okay. Sorry, made a mistake. Okay, that's another one. Let me see. Okay, so a discovery. Okay, great.
Okay. So can we move to the next one?
Okay. server discovery. What is this? Oh, let me do.
So just that the current status of the draft. So there is a call for adoption that was issued. So from our side, we think that there is a fair support for this document. But as I mentioned there, I'm still waiting for I would say the formal a conclusion from the working group chair whether we need to proceed or not with the revisions of the draft.
So this is Roman Dinidio apologizing in the chair role. I did not close it, and Frank and I have kind of spoken, and Valerie has spoken, and we concur in the January timeframe that we had support for it. We just didn't hit the button, and I turned it to the active chairs to fix that.
Cool, thanks. So going to technical discussion, so we received multiple I would say comments from their editorials and not editorials. We have selected two of them that are more technical. The first one is whether we really need to have 4 ways to discover the server. So this is really a fair comment, and this is not the first time that we received it. We were already there, and this is why we have a dedicated section in the draft to explain why multiple discovery is really likely. And we cannot just say that we have to go for DHCP or we have to go for DNSSD or this kind of stuff, because there are multiple deployment contexts, and we need to accumulate as much as possible the deployment scenarios. In the draft, you have a unified mechanisms to prioritize all these ways to discover the server, and also some recommendation in how which method need to be implemented. There's at least one that must be implemented, and there is recommendations to order the various mechanisms so that there is no problem at the DOTS client in determining its DOTS server. That said, we do think that there is a room to mix some, I would say, remove some of them, and we have identified the unicast one and the multicast DNS. Personally, I am not that fan of the unicast for the DOTS server and also for the MDNS, but this is something we need feedback from the working group, because I am not, at least in the deployment cases I am targeting, these ones are not in my list. So, but I want to remove them just because it's not my favorite option. So we really need to hear from the working group whether we need to maintain them, or we need to, if there's no, I would say, someone who is in favor to maintain this kind of ways to discover the DOTS server. Any feedback so far, or?
Yeah, I mean, if Anycast has problems in multi-homing and you want to make the client aware of the deployment model, it's going to make the life more complicated. So pick other ones which work in all the models, right? And if DNS service discovery is already there and you know the network domain name, you don't really need MDNS. MDNS, DNSSD are just flavors of the same discovery. So DNSSD works across link local, so you can just stick with that. So you're not going to lose anything by removing MDNS.
Exactly. Okay, so please, feel free to send any, I would say, if after the meeting you think that this is something which needs to be maintained, just send us a note, and then we will take it into account and discuss it. The second one is about to clarify the overall model, because in the DOTS, you may discover the DOTS server IP address, but if you don't have the credential to do the authentication, this is useless. So far, what we have considered is that we separate the service with the credential provisioning and the authentication from to find where the server is located. So we assume that the provisioning is done beforehand, and then once we have this kind of information provisioned to the DOTS client, the DOTS client can start say, where can I find my DOTS server? And this is what we are focusing in this draft. So we will add some text to clarify this overall model, to say that we are separating both, and we are not here to discover the security credentials. We are not here to define new methods to discover the security provisioning matters. There is this comment which is really, for me, an interesting one, is about the triggers to run the discovery. For instance, so far, you can run the discovery during the bootstrap. You start your DOTS client, it starts to discover the servers, but then the question, should the DOTS client maintain the list for all the time, or till the certificate expires, or till which trigger? So we need to be really, I would say, precise and specific in the triggers so that we can rerun again the server's discovery procedures. Of course, there are, I would say, triggers that are specific to the protocol itself, because if you discovered, for instance, the DHCP reference identifier for your .dot server, you have a list for that. So you will wait until this is expired, and then you will run the procedure. This is simple for the DHCP. This is not for other methods that are specified in the draft. So we will need to think about this more and to include more triggers in the draft so that this is something which is more deterministic. Any comments about this point? So for the next, the first bullet, we don't need to wait anymore for the conclusion. So because the conclusion is communicated to us. So then once we will publish the adopted version, we will start to shorten the list of the mechanisms there, and to include more text about the triggers and the overall rationale. And of course, if there is any comments from the working group, we will be more than happy to integrate it and to take it into account.
So any question, comments? I have a question. Do you plan to, after your this round of update the document and then become a working group draft, or you think that currently it's okay to work group adoption?
I think that's.
Should we wait with this update?
The simple way is that I prefer personally to do things in the IETF, the procedure and so on. So we will first publish it as the first version won't include any modification. This will be the same version that we have during the call for adoption, and then we will take our time to think about the modifications, and then we will release the new version before the next IETF meeting.
Okay. Thank you. Okay. So I think just like Roman just under the microphone has said that this document actually we have already asked for the working group working group adoption in the main list before, and I think here now is the time that we can continue this process and adopt it. And of course, it doesn't mean that it's good enough. It just means that we accept it as a work item for the working group. So there are still a lot of modification, improvement on them. Okay. And I think we have several new use case and new extension draft this time. So the first one is, let me see. Oh, yes, this one. Drew, it's your turn. This is about the signaling channel call home mechanism.
Thanks, Frank. Yeah, this draft was presented in the last IETF, so I'll give a quick recap on the problem statement and solution overview before I go into the updates that we have done for the draft. I think there's some problem. Yeah. So today, right, I mean, many of the ISPs have DDoS detection and mitigation capabilities, and they detect outgoing DDoS attacks coming from home networks and enterprise networks. But the problem they face is they cannot identify the actual culprit device within the home network which is generating the attack traffic. So ISP cannot quarantine or isolate the infected device within the home network. And the heuristics or the DDoS detection algorithms that the ISP uses to detect DDoS attack may not be deterministic. For example, it could be a flash crowd scenario where legitimate traffic will be misclassified as an attack traffic. What the ISP could do is basically rate limit or block the traffic from the home network, which would cause a bad user experience and result in customer calls. Now, nowadays there are many vendors providing network services on home routers, and they may or may not have the capability to detect new emerging and sophisticated attacks, but the ISP does have the capability to detect those emerging attacks. The challenge that we see today is many people think that, hey, though my IoT device is infected, it's just attacking somebody in the internet, so who cares, basically, right? But the whole problem is, since you have an infected device at home, it could be used by the botnet controller to do some other mischievous activities which could target the home network itself. For instance, it could be used for crypto mining. If your home security camera is being used to launch DDoS attacks, it could be also used to send the feeds to the attacker, so he can that compromises the home network security and privacy, right? So it's a bigger challenge that though DDoS attack is an attack on somebody else's infrastructure, ultimately the infected device could also be used as a launchpad for attacking the home network itself. The quick solution overview is, in this case, unlike a DOTS client and server, the DOTS server, which is going to initiate a DTLS session with the DOTS client, and whenever any attack traffic is initiated from the home network, and the ISP either detects the attack by its own, or it receives the ACL filtering rules from upstream ISPs using BGP flow spec, it can send a mitigation request. The new addition that we had added is the attack information, the source who is attacking the victim. And with that, what the CPE can do is it can look at the NAT logs and identify the infected device. It can inform the user. It can even isolate the device from talking to other devices within the home to avoid it basically spreading the malware to other devices within the home, and block the attack traffic to the victim. And as the attack traffic is blocked, it can send a mitigation status update saying that the attack traffic is successfully blocked. We received various comments from the working group to say that how can a CPE handle multiple signal channel sessions. So the clarification is, in this case, the DOT server is going to initiate only one signal channel session, which is one DTLS session with the ISP. So it's not going to be a conventional DOT server that we typically see. Further, to clarify, if carrier-grade NAT is located between the DOTS client and DOTS server domain, then the client is not aware of the external IP addresses and ports. So it becomes the responsibility of the DOTS client to basically send the internal IP addresses and port numbers, which the DOTS server can identify to recognize the internal host which is launching the attack. So RFC 8152 and 8153 define the YANG modules which the ISP can use to identify the internal IP address and port to map them to the external IP address and port. In case if MAP or LWAF-PTR is used, in which case there's one public IP address and a restricted non-overlapping port range that is assigned to each home network. So the port range assigned to each home will be used to identify the home network that's launching the DDoS attack traffic. And typically NAT is involved on this home CPE, so in that case it would just have to look at the NAT logs to figure out the internal source IP address and the MAC address of the compromised device. It can inform the user, isolate the device from talking to other devices in the home, and block traffic to the target. We've also done several updates to the security consideration sections, especially to handle a case where the DOTS server need not blindly trust the mitigation request from DOTS client. It's following the same principle as the DOTS signal channel protocol, that the request is just a hint. It's up to the DOTS server whether it wants to take any action or not on the mitigation request. For instance, on a home router where full deep packet inspection is not enabled, it can be enabled to look at all the traffic only from the compromised device to the target, which is a flexibility that many of the home routers like Broadcom and Lantic provide. The other solution could be to redirect or clone the traffic from the compromised device to the target to a DDoS detector or a DDoS mitigation system to cross-validate the mitigation request that was sent by the DOTS client. And the last one is to seek consent from the home administrator to take appropriate mitigation action. There has been also various comments on the privacy considerations that it could be used for censorship or basically to ease surveillance, but we have clarified in the draft that DOTS calls home extension is only advisory in nature. The DOTS server need not reveal the device type, make, and model to the DOTS client, so the ISP would not know what kind of device is generating the attack, other than that there is only one, there is a device which is generating the attack. The cross validation by the DOTS client, by the DOTS server, would help the dot server to validate whether the mitigation request was authentic or not. And then we added the administrator consent check. The overall solution is that with this, what happens is that it's not only going to protect the target resource from attack and block the attack traffic closer to the source, but also protect the home network, that the home administrator now knows that he has a compromised device in his home network. We have addressed all the comments received from the working group, and it looks like a stable version to us, and we would request working group adoption of the draft and would welcome any comments and suggestions on the draft.
Okay, comments?
Timur Gorichenko, Curator Labs. Thank you for bringing this. Thank you for developing this. One comment I may have is that if we look at the problem statement, but only subtract the word home from that,
okay,
the problem statement would be equally valid.
Right.
Maybe after the adoption, but have you considered changing the word home to something different, like access or something different? Because this is a solution which could be also available for corporate networks as well, not only home.
Yeah, it's definitely applicable to even enterprise networks. And we thought, since Mirai attack was very large, popularly seen on IoT devices, and it's compelling to basically highlight that as a problem. But the use cases could be various other deployment scenarios as well. I totally agree on that.
Thank you.
So can I follow this gentleman's question? I'm also interested. I think I have discussed with Thiru before. This is a general solution for a lot of use cases, not only for home network. It's also for the DC or for the end branch or for the carrier interconnection, right? So what's your answer? Also, what's your solution for this required? How we clarify this point in your draft?
What we can do is we can take home network as one use case and probably add the other ones as other. We can add one more section to say this is equally applicable for enterprise DC or ISP networks.
What should be considered probably then is the discovery mechanisms of the server, which could be different for home use case, enterprise use case.
Yeah,
so this is something to
right.
follow
So
up on.
the dot server discovery draft that Matt just presented handles all the cases. So it's not specific for home networks. It works in both enterprise and access network cases.
Yep, thanks.
Okay, thanks, Thiru. I think, no more comments. Okay, so I think this draft is stable. Yes, we have several rounds, discussion and the presentation and improvements. I think it's stable. Yeah. So we are planning to send to the main list about the working group adoption. And everybody, please read this document and read your comments or your voice about this document. Okay, thank you. Okay, next one is Yuhei. This one.
Thank you. So this presentation is DMS off-road mitigation, DMS off-road use case. This is agenda. First, I want to explain about why applicability document, and second, bullet point of my draft, and finally, I want to explain about the POC of our use case. First, so my document, why applicability statement document I wrote is that to identify innovative deployment schemes to motivate the use of dots, such as optimized scrubbing, invocation, and so on. And second is to providing information documents is helpful to see dots deployment reality a commercial network, especially network operator company. Next, this is a bullet point of from my previous draft. So I simplified our proposal. Current document writes collaboration DMS and orchestrator and forwarding nodes. And I withdrawed our expansion of signal channel for the moment. It because to reconsider a requirement for expanded signal and data channel for my use case. And I divided our use case into two cases. One is a dot request via outbound link. This use case, in this use case, a DMS sends offload request to orchestrator via outbound link. And in this use case, DMS use data channel. And second applicability use case is that in this case, DMS sends offload use case to orchestrator by using signal channel. And this slide shows that motivation of using dots. About the case dots request via outbound link. So Acrylian model can send information about identification of dots clients request, but dots can send CUID, so orchestrator can identify DMS offload request. And about second case, dots request via inbound link. The motivation of using dots is in attack time, link is congested, so a signal channel of dots is suitable. And we demonstrated a proof of concept of our use case, especially outbound link. And this figure explains the environment of our proof of concept. And in this environment, DMS AMP attack hits a network, and target traffic is already mitigated by a DMS. From this session, our use case is carried out. First, DMS sends a syslog. DMS sends a syslog about a block traffic traffic information, and a DOTS client extracts information of block traffic information from the syslog, and then DOTS client sends the ACL in data channel, and finally DOTS server Go BGP DOTS server invoked Go BGP, and Go BGP sends a BGP flow spec to set P router filter configuration like this. This is the next action. So far, received comments were all addressed. Thank you for giving me comments. And I think it is important to document applicability statements to help see DOTS deployment reality network. And so we request the working group to consider adoption of our use case. That's all.
So your request is a working group to adopt your use case. New use case.
Yeah, new use case.
I'm not sure because our current use case document, working group document, is progressing to the very later stage. I don't know what is Sheffield's or AD's idea. Okay.
This looks like a use case which is completely different from the use cases that the use cases draft have discussed. But if you could go back to your figure that you had mentioned that you're planning to use. Next slide. Next one, please. Next. Yeah, here, right? See, if you see, right, I mean, the DMS is basically going and telling the orchestrator that for this DOTS client, right, for example, in an enterprise network, I'm not able to handle the attack, right? but the CUID is actually supposed to be the DMS, the client's CUID, right? It actually needs to tell that the enterprise X is the one for which I'm not able to handle the mitigation. And then the orchestrator might either program the PE router saying that do the filtering, or it can offload the DDoS mitigation to like what we have discussed in the recursive signaling draft, that it could be handed over to something else. This use case seems to be resulting to me in some enhancements to the existing core specification protocols, basically, right? You cannot use CUID for a client and say that I want to do a offload for by a DOTS client, right? It's two different ones. CUID is supposed to be an identifier of the DOTS client, right? Now, when you DMS is saying on the behalf of a client that, hey, I cannot handle the attack, it needs to be conveyed in some other way. And CUID is not the way of conveying that.
Thank you for comments. So I will consider about it.
Right. So I think you need to highlight this use case in a way that it's an extreme scenario when the DMS is not able to handle the attack, right? Then when it signals this information, how does the DMS orchestrator identify the client? What kind of policy it could take? The policy could be to offload it to some other ISP or some other cloud DDoS mitigation provider to handle the attack, or it can use this information to program the PE routers, basically, right? So there are 2-3 use cases that are there. I think you should list them and probably modify or extend the protocol draft in a way that the client information is conveyed in the right way, rather than overloading the CUID.
Thank you.
Yes. So one clarification about the term use
Hamid,
case. Yeah.
your name.
Mohamedou Kader Orange. So this is not actually a use case document. What we try to do here is it is more an applicability statement of the DOT specification. We have in this working group we produced so far, and I hope that this will go into the RFC stage, the signal channel and the data channel. And if you want this specification to go into deployment, we need to assess how in some specific cases, how this specification will be applied in this specific context. So the language and the details of the information that will be included in this kind of documents will be different from what we are seeing today in the current use case. So this is really a clear distinction that I'd like to make for this draft. And why this is important? Recently, I was involved in an internal RFP in which we are dealing with DDoS and so on. And when it comes to DOTS and so on, people, they are not where we have to put the DOTS client, where we have to put the DOTS server, which interface should I what kind of behavior. So we need something from the working group to help at least to provide some applicability statement, or if we want to help and to see the DOTS solutions deployable. And that's really a key point to comment here.
So you want to bring some to help us to clarify this point in working group, because I think current our use cases or all our documents just specify parts of the deployment models. Maybe they propose some new models, right?
So, yeah, for me, this is only one part of the puzzle. There are other puzzles, how you will interact with the mitigator and so on, whether we use the DOTS and so on. So
right now, it's out of scope.
It's so far it's out of scope. But if you want to provide, you have to show this various puzzles. This one is important because we are using the DOTS to do the offload. Making the offload, for me, it's not an extreme case because the scribing center may be exceeded by the capacity and so on. And by reusing I would say, the filtering capabilities, which is already in the routers, you are just leveraging all these capabilities and you are providing the service because you are just targeting the top, I would say, prefixes that are contributing to an attack. So for this to happen, we will need to use the call home extensions, for instance, and then we have to coordinate with the orchestrator, which is not, by the way, in an external domain. It may be in the same administrative domain, both the mitigator and also the orchestrator. It's just a way so that you have to, I would say, to orchestrate all the various pieces that are contributing in the DOS mitigation to provide the service efficiently.
Ben Kaduk, so putting on my AD hat, there's a few relevant points. So first, we do have the requirements document that hit the ISG and got a little bit of feedback about, given that the signal channel and the data channel are already basically done, do we need to publish this? Is there archival value? Somebody even noticed that there was the use cases document, the working group use cases document at the time, and also wondered if we want to publish that as an RFC as well. So you might take that as input, in terms of your eventual goal for this document. It is certainly reasonable and can be useful to have the working group adopt a document and run it through working group last call to say, yes, this is something we agree upon. But just because the document has working group consensus, whether the working group wants to publish it as an RFC is maybe a separate question. So that's an issue to think about. And then a different topic. So you've been sort of using the term applicability statement. That's actually a technical term in the IETF. If you look at RFC 2026, and applicability statements are in the standards track stream. So there would be a very stringent quality threshold on such a document in terms of really laying out how do you specifically use the technical specifications for this particular use case. I don't know that you necessarily need to do that here. It's okay to have sort of a more informal document that says, these are some pieces you can throw together and scenarios that you might want to use this stuff for without going to that formal level. But it's probably best to avoid calling that an applicability statement if you want to do that.
So can I confirm what you have mentioned? So do you mean that if we push this document quickly and it's reasonable and we reach consensus in working group, we still can add it to the current working group use case draft? No?
I did not try to say anything about that.
Okay, sorry.
I mean, I guess technically you could, although I think some of the previous comments at the mic line were saying that it might actually make sense to have them separate.
Okay, thank you.
I think having this draft is useful to know how ISPs are deploying this and the kind of challenges they are facing. Not just focusing on this specific problem of hey, DMS is congested, but in general, having a draft discussing how operators are deploying DOTS protocols and how all the entities are talking to each other, what other non-DOTS protocol they are using. For example, the controller talk to the other ones. Probably if it's just info, even if it's information, it's going to be really valuable for somebody who wants to deploy DOTS in their network or somebody who's deploying protocols to understand what kind of other actors are involved in deploying DOTS.
Okay, thank you. I think we should have more people to read your draft and more discussion on the main list.
Okay.
It's really a new document, right? So we need time. Okay.
Oh, thank you.
Ben Kadek again. Sorry, I had too many points to keep track of in my head. A similar comment to what Tira just said. Thank you for writing this down. It's definitely important to have written descriptions of what people are doing, and it's very useful. Whether or not it ends up published as an RFC or not, it's still very useful. So thank you.
Thank you. Yeah.
Thank you.
Okay, next one is China Mobiles. I think that's another use case and first release use case, right?
Hello everyone, I'm Chen from China Mobile. I'm the last one to do the presentation. This IETF conference, we have submit 2 individual drafts to the conference. Okay, let's look at let's make a brief look at the China Mobile's. Sorry, I'm a little nervous.
Take it easy. I'm also a little nervous, always. So take it easy.
Let's look at the China Mobile's mitigation architecture of the DOS. From the picture, we can see that in our backbone network and main exit and IDC, we have deployed the clean center there. Let's start the attack bypass expansion. Why we need to expand the parameter of attack bitewise is because that we list 3 use cases here. The first one, as there are many cloud cleaning service provider. It is very expensive for the equipment and the bitewise. So with the parameter of attack bitewise, it is really useful for the optimal cleaning depth selection. And in Phase 2, as the role of ISP, we are very care for the bitewise usage in our link. If attack occurs, it have to be to do the BGP redirect. So how to select the best place for the mitigation? In our China Mobile, our internet bitewise threshold is no higher than 17%. So when big traffic attack occurs, it is really valuable for us to select a best way to the protection center. And in the use case 3, it's really an extreme large furrow. If it occurs, we have to throw away most of the traffic, but we don't want every one of our customers to be shut down. At least we have to ensure the minimal success rate in our exam. We can see that we can ensure about 10% success rate. This is another individual draft of target attack type expansion. We have to do the research that different vendors are good at handling different types of DDoS attack. So we have know that from the background of China Mobile architecture of anti-DDoS solution. We deploy the detector upstream the IDC. So when our customer customer suffers the attack, the detector can detect the attack type and inform DOS client then send message to the DOS server. DOS server then ask mitigator for help. With the attack type, it can do the mitigation immediately. So it will shorten the mitigation time. And usually the DDoS attack are mixed traffic attack, such as mitigator A is good at connection less fraud, and mitigator B is very good at HTTP/CC attack. So when the mixed traffic comes, the DOS server can ask both mitigator A and mitigator B to do the mitigation. That means that mitigator can do coordination mitigation. What else can we do if extend the attack type parameter? For DOS client, when it receives the response with attack type, it can verify the attack type by itself, and different vendors can adjust the detection strategy here. For the DOS server, what he can do that with the extension parameter of attack type. Sure, it can do analysis of malicious reporting nodes. It is sure that not every DOS client are to be trusted. It can be maybe some fakes. And from the perspective of management, we can, with the parameter of attack type, we can convenient do the management. For example, we can show detailed information to our customer about what's the attack occurs. And in this draft, we also do another thing is to do the unified naming format. We have researched that there are 3 vendors in our country, and we just make they have just make 13% agreement rate of the attack type. I just mean the name. So
can I ask you a quick question? What are the difficulty? In this page, it brings to you. They have only 30% overlapping. So what is the difficulty when you use and have different kind of attack type?
Okay, it is sure that we China Mobile have many vendors equipment. We have to manage them together. So option for them to each other is really very important.
I mean, do you have any simple example when, for example, in your network management system, you receive different kind of information, but actually they are possibly the same. How do you deal with them?
Oh,
just an example. That's my example. I don't know if it's right.
Yeah, I can explain it. If vendor A provide with HTTP SIM card and vendor B provide the SIM card, we don't know it is the same. If it is same, so we do make confused about the type.
Thiru, I think this draft brings in a lot of things, right? I mean, one of the things was the DDoS telemetry that the working group had discussed a couple of years back. And since there were hints and not mandatory for the MVP of the protocols, it was discarded. I remember Radware had published a draft basically talking about various telemetry details, include bandwidth and DDoS attack types. The problem with DDoS attack types was at that time, if my memory serves right, it was the problem that there are at least 50 to 60 different attack types, and there is no global registry which can map all the attack types. And further, nowadays, most of the DDoS attacks, if you download a simple Mirai attack that's there in the internet, right, which you can download and try it for yourself, they're all multi-vector basically, right? So they don't attack a single protocol layer basically. So the command and control can program the botnet to launch multiple attacks both at L3, L4, L7, right? So if a vendor is incapable of handling all the layers of attack, then it's going to be really difficult to handle even a single DDoS attack, which typically spans multiple protocol layers.
Sorry, I don't got your question. Can we discuss in the email, or you can speak again slowly?
Sure, we can discuss on the email. But my point was, we had discussed these problems before, and the working group had decided not to pursue them. So now that you're bringing them again, maybe now that the core specs are done, maybe there's renewed energy to look into that. Maybe we should discuss them again. But this was discussed previously, both bandwidth and attack types.
Yes, I remember. I think Thiru just brought some history of this working group to you. You are very new, but of course we can discuss to tell you some story about this kind of attack type and tracings.
Okay. We can see in our slide. Oh, sorry.
No, my suggestion was to listen to the end and then continue with questions.
I can. Okay. In upstream of our IDC, we can do the detector. So a detector here we can as a DOS-Quite. And the DOS-Quite then reports the attack type to the IDC current center. So in this scenario, we think attack type can be trusted. Okay, your question?
Yeah, is that all? Because I was, I thought there's more slides in the presentation.
More slides?
No, more slides. No, is it the end?
Oh no.
I think he has. Maybe you have finished all of your presentation. I think.
Oh no, I haven't finished.
Okay, so maybe we can have some comments firstly. It's a quick one or.
Oh, I can continue my presentation.
Okay.
Okay, this is the last slide of my presentation. It's about the syntax of our standard attack type definition. We have defined the protocol level, protocol name, and these two fields are mandatory, and for the three are optional, and the last one is the mandatory. Is the attack methods declared in the stand field, and the table next is the example of it, and that's all my presentation. You can make comments.
Thank you, Tema Gavrichenkov. So first, I agree that it would be very hard to convince all the vendors for a unified attack type naming. It may not be a limiting constraint because we had the same thing, for example, with 3GPP monitoring events, and we just needed to maintain the mapping tables. So that's sort of solves the same problem. The issue, though, is that first it relies on the on a particular type of architecture of a DDoS mitigation solution where you only filter what you know, the attack types you are aware of, and allow for the rest. Well, this is only one of obviously two ways to do that. The second being that you only allow what is typical for your network and disallow everything which is non-typical, no matter what that is. That's first. Next, I totally agree that even in that scenario, you will, and I believe that was said before, you will have a problem with, you can call it zero-day attacks. So those are which are not in the in your unified format. And while it will take probably about a month or so for a vendor to issue a fix, but to change a unified naming, that will probably take a year. So it's not quite clear what you are proposing with that. Finally, I don't, so this mandatory field called protocol level here, and I don't quite understand the reason for it being even there, let alone mandatory. If you could explain that, that would be interesting to hear.
Maybe you can discuss on main list. We are near the end of the session.
Yeah, sorry,
yeah,
okay.
Yeah. Okay, or discuss offline. Okay, thank you.
This is Wei Pan from Huawei. I feel that the draft has two premises. The one is that the different vendors, the mitigation devices have different capabilities, like the bandwidth. And then the second is that different vendors are good at handling different types of DDoS attacks. And this is what motivated that you bring your use cases here. That right?
Right.
Yeah, I think that this motivation is quite reasonable, and the premises is reasonable too. And I think, but the expansion maybe need to more discussion. But I think the use case is valid.
Thank you.
Okay, last one. Yeah.
Hello, Roman.
Hi, Roman Danilio. First off, I just want to say thank you as an operator, kind of bringing your use cases to the IETF. It's great. So thank you kind of for doing that and pulling that together for us. I have a couple of detailed questions. I don't think we have time based on how Frank is signaling. So the one thing that I would say is, in both drafts, if you could describe how you're planning to do the extensions, that may kind of help talk through the taxonomy side of the attack and how you're going to put those fields in. So I think you're going to use the signal channel, the IANA registry proposed by the signal channel to add the fields?
Yes.
Okay, because of time reason, I think we are on time finish all the presentation. Yes, thank you for everybody join today's session. And previously we have arranged some discussion about our next step, but you can see my screen. Actually, I don't think we currently need to do a very big recharter or extension to current work. So let me show you. Sorry. So I just want to say right now we are considering the possible new work in working group. And here we have some examples, some of the provision in fields which we have already discovered at multi-homing and discovery, software discovery, and we have new use cases brought by our operators. So that means we may have some new work here to do. So please, everybody, read all these new documents and provide your comments on main list and have more discussion with, among each other. So let's see what we will do in the next step. I think we will have some decision in the main list not very long. Okay. Yeah. Thank you for your time. Thank you. See you in Montreal. Okay.